So, as Helmut mentioned at the start, we're very grateful that Glenn Suter has been able to come and substitute for Steve Rotten. Glenn is from the US Environment Protection Agency, working as a senior advisor in the National Center for Environmental Assessment, including integrated environmental assessment, I could see in your biography. So a man after my own heart, at least. Glenn is also a fellow of the American Association for the Advancement of Science and has hundreds of publications on various aspects to do with the topic that we're discussing. Glenn.
Thank you, and thank you all for coming this morning. I'm going to continue the theme of ecosystem services and biodiversity, because that was what I was asked to address, and take a little different North American view than Lorraine's, but I believe it's complementary and certainly not contradictory. As both Lorraine and Alan have said, we begin with goals for the environment. They're set by legislation. The US Clean Water Act requires that we protect the physical, chemical, and biological integrity of the nation's waters, which is a wonderful goal. But it's very hard to assess the risks to that goal. Scientific assessments require more specificity than that, and so back in the early 1980s, actually I developed a concept called assessment endpoints that some people have picked up on. I'm tempted to become nostalgic and start talking about the early days of ecological risks and how we developed concepts like problem formulation and so on, but I'll restrain myself. Assessment endpoints are defined by an entity and one or more attributes of that entity. For example, the species composition of a biotic community is an assessment endpoint. But it's implemented using measures of effect, the results of toxicity tests, of analysis of field data, or whatever. An example is a species sensitivity distribution of a relevant effect metric on the species or the entity in that case. And the question very early on that we were asked was, what makes an appropriate assessment endpoint for regulatory purposes? And for example, I was asked by an EPA manager early on, this was before I joined the agency, what is cancer for ecosystems? You know, they knew how to regulate based on cancer risks. So what did we have to offer that's equivalent to cancer risks? And we provided a policy document that addressed that in 2004. The Risk Assessment Forum of the US EPA developed generic endpoints for ecological risk assessment, so that if a manager asked an assessor, what is the policy basis for protecting this, you know, what can I stand on if I'm challenged for protecting this endpoint? You can now point to the generic endpoints. They're based on legislative goals, regulatory language, and precedents. Examples are for populations being the entities. The generic attributes are extirpation, abundance, and production. We have good precedents for those. And if the population is a population of an endangered species, we also have a good legal standing for protecting the area and quality of their habitats, whether or not we can demonstrate an effect on a population attribute. Ecosystem services came onto the scene rather late in this development. There was a recognized need for ecological assessments to be relevant to more people. Effects on conventional attributes can be translated into changes in provision of ecosystem services, such as production, which are called production functions. if nothing else, they're useful for communicating ecological risks to decision makers and stakeholders. Even if you're not doing an economic analysis, cost benefit, whatever, it's still useful to address ecosystem services. But it can be translated, the ecosystem services can be translated into economic benefits much more readily than the conventional ecological assessment endpoints. So we have been developing generic ecosystem services endpoints to go with the conventional generic ecological endpoints. These documents aren't yet published, but we're very close. And one of the things that I want to emphasize is that ecosystem service endpoints supplement conventional ecological endpoints. They don't replace them. We protect the environment as required by law, even the components of the environment that don't provide an identifiable service. If you're interested in seeing where we stand in developing those policies, this open literature publication got a little ahead of the official documents. So you can go to Integrated Environmental Assessment and Management for a paper by Munz et al. On ecosystem services as assessment endpoints for ecological risk assessment. I'm not going to spend any more time on generalities. I think it's more interesting to talk about cases. This is mountaintop mining and valley fill. You can see there in the center of the picture, a mountain is being removed to get at the coal. You can see some coal seams there in that cut face. And the overburden, the rock on top of the coal and between the coal seams, is crushed and used to fill valleys, as you can see on the extreme right. There's a valley that's next to this ridge that's being filled with crushed rock. If you look at a valley fill from the base, you see a settling pond here in the front, but I think you can imagine with this huge volume of gravel, effectively. When it rains, when the snow melts, it percolates through that freshly crushed rock. The rock dissolves, and what you get out at the bottom is a rather concentrated solution of dissolved rock. This is in central Appalachia and West Virginia, Kentucky, and Virginia, and other adjoining areas. And the waters here typically have a specific conductivity of about 150 as background, or even less. Water leaching out of the toe of these landfills is often above 1,000 microsiemens per centimeter. So it's a big change. And so even though people wouldn't think of dissolved crushed rock as a toxicant, it is. They are toxic to these organisms because they're not accustomed to this kind of water. They have strong ionic management systems that are based on the assumption that they're living in relatively pure water. So we see some patterns of occurrence here. The x-axis is log conductivity, and the response variable is probability of occurrence at a given conductivity level. Some of the genera, like Lepidostoma, like it very pure and decline rather rapidly as conductivity increases. Others have an optimum within the range of observed conductivities. And there are even a few who like a nice high saline water like the caddisfly Chematocyke. So if you look at, if you take the 95th centile of each of those distributions and say that, above that line, the genus in this case is extirpated. Effectively, it's gone. And then you plot all of those 95th centiles, you end up with a species distribution, an SSD. You take the 5th centile of that and say if we set a benchmark at that level, then we're protecting 95% of the genera in these streams. And we've done that. It comes out to about 300 microsiemens per centimeter. And that's all well and good. The benchmark is good science. It passed multiple peer reviews. It's published in the open literature. It's approved by our science advisory board. But when I presented it to a state official in Kentucky, he said, well, what are mayflies good for? Because most of the lower end species in that species sensitivity distribution are mayflies. There are a few stoneflies mixed in and some other things, but it's mostly mayflies. And that was familiar to me. It reminded me of a Superfund site manager some years earlier when I suggested remediating an embayment that was contaminated by PCBs and mercury to protect the benthic invertebrates. He said, why should I care about bugs in the mud? So those sorts of questions arise. Also, I would guess with respect to pesticides and streams, so to make this all relevant to the theme of this meeting, because the insects are the targets for insecticides. And ecosystem services can help to provide answers to those kinds of rude questions. The obvious thing is that aquatic insects are food for larger animals, including fish, amphibians, birds, bats, semi-aquatic mammals. The format changed as we go from the US PowerPoints to Europe PowerPoints, so we're going to be missing things here. But the service of providing food to fish, which are caught by fishermen and eaten by humans, is the obvious ecosystem service. And when you see discussions of ecosystem services, that's with respect to streams and other freshwater systems, they're very fish-centric. That's the thing we know how to do. And they often stop with that. They don't go beyond fish, and the presumption is if you identify that one service, you've got it covered. And I'm going to argue in the rest of this talk that we should be going beyond that. Stream insects perform ecosystem functions, which are the kind of things that people who work on ecosystem services are paying more attention to. Nutrient retention was actually the one that the Kentucky official really responded to. He said, you mean by stopping valley fills in Kentucky, I can help to reduce the Gulf of Mexico dead zone? And I said, sure. Why? But nutrient retention actually has important local consequences. The aquatic insects, the mayflies, stoneflies, caddisflies, and so on, when they emerge and after they mate and lay their eggs, most of them actually end up in the terrestrial environment. So when they're in the stream as larvae, they're capturing nutrients that are being washed out of the watershed, and then they're returning them to the watershed after they die. This is not the sort of thing that comes to mind immediately, like fish eating insects, but it's important to consider. Litter decomposition, the scrapers clean rocks, they participate in element cycling, they stabilize stream beds. That's one I didn't know about till we started doing the research, but caddisfly nets actually reduce sediment resuspension in streams. They enhance the stream recovery. They remove suspended algae and pathogenic microbes. All good ecosystem services. We can, and we do, then create a conceptual model like this that shows how the various services of the aquatic insects are linked to each other and how they connect from intermediate services to terminal services like increased lumber and firewood from watersheds that have been fertilized by dead insects. But there are other sorts of benefits of insects that don't fall under the conventional ecosystem services rubric. They're indicators of water and sediment quality. We use indices based on invertebrates to determine when the water has become toxic. We use them as models in recreational fishing. You know, all the fly fishermen model their flies on mayflies, stoneflies, etc. And if we had an ecosystem, stream ecosystem without these organisms, you know, you would probably still have ecosystem services performed by oligochaetes and mollusks, and there'd be evolution to fill all the niches that the insects left, but you wouldn't have any fly fishermen anymore. Creeking, you know, kids go out in the streams and they wade and they turn over rocks and they get turned on by the bugs. There are educational programs based on aquatic insects and in particular mayflies. Collecting and watching, photography. There actually, if you go on the web, there's a site called Mayfly Central that has thousands of recreational photos of mayflies. And you know, and one that really intrigued me is literary images and metaphors. There's a huge list of poems that include mayflies. They're an important literary image because they're ephemeral, ephemeroptera. They, you know, famous for only lasting a day. And if people grew up without seeing mayflies, they'd have a hard time appreciating that literary metaphor. They're commercial and recreational symbols. And the Nike company makes a mayfly running shoe. There are bases for art and design. Their potential have physical and chemical products. And the picture here is a use of aquatic insects that you may not have thought of in making jewelry. The caddisflies are placed in aquaria with flecks of gold and semi-precious stones and pearls, and they turn those into beads, and the beads are used to make jewelry, and quite pricey jewelry, in fact. So for more on services of aquatic insects, once again go to the journal Integrated Environmental Assessment and Management. This year, Susan Cormier and I published a paper, Why Care About Aquatic Insects, Uses, Benefits, and Services. And in summary, I want to say that even if you're not performing an economic analysis, ecosystem services are useful and I would argue very important as communications tools. But don't stop at the obvious economically quantifiable services. Quantify what you can, but describe the rest. You know, overwhelm them with how important these bugs are, or whatever it is that you're protecting. Because even a mayfly can be a thing of beauty and a joy forever. Thank you. What happened to my mayfly?
Thank you, Glenn, and thank you for painting a canvas of ecosystem services that I hadn't seen before when you showed that second list. Okay, we have some time for questions to Glenn. At the very back.
Hi, my name is Vinicius from Federal University of Santa Catarina, Brazil. My question actually might be not very related to what you talked, but there are some studies from our collaborators in Norway, Ecological, that they showed some effects of herbicides in the aquatic model Daphne magna. So I would like to know if you think the herbicide problem would be affecting also the aquatic insects? If this would have some impact on the food chain of the insects and so on? And if you think this kind of studies should be taken in account of risk assessment, environmental risk assessment?
Yes, I think obviously that it should. And this raises an issue that I didn't get into in my talk, which is that we know relatively little about the sensitivity of these aquatic insects. As you pointed out, the standard aquatic arthropod that's addressed in toxicity testing is the cladocerans, like Daphnia magna, Cereodaphnia dubia, et cetera. And there's really not very good representatives of aquatic insects. And to the extent that we do test aquatic insects, we tend to test dipterans, which tend to be really tough bugs. We don't look at mayflies, stoneflies, those sorts of insects. And there's a lot of evidence from the field, more than from the lab, that these insect groups are not well protected by Daphnia-based testing. Will Clements at the University of Colorado, for example, has shown that they're very sensitive to dissolved metals, and our current water quality criteria in the United States aren't protecting the stream aquatic insects.
Our pesticide friend again.
Mm-hmm.
Thank you, Martin Dermine, Pesticide Action Network Europe. Thank you for your talk. I had a question. Now, EFSA seems to be heading towards an ecosystem services environmental risk assessment. And you mentioned that in the US, the ecological aspect is still taken into account and is supplemented by the ecological eco-services risk assessment. Is it due to the fact that, for instance, you believe that many things we don't know and that still we have to preserve all biodiversity, or is it some kind of cultural thing, thinking that we cannot harm anything from the environment?
Yeah, well, I suppose it is a cultural thing. It's also a legal thing. You know, in the United States, we have laws that say that we need to protect the environment. We need to protect species in the environment. And we're doing that, and we'll continue doing that even as we add ecosystem services to the list of things we're protecting. You know, we're not going to be limited to only those endpoints that perform identifiable and quantifiable ecosystem services.
Okay. Thank you. I'll take one more question, and then we'll move on to the next session.
Thank you, Jose Tarazona, EFSA Pesticide Unit. Thank you very much for the presentation. I think that it was excellent. I think that just to answer the question, I don't think that the approach that EFSA is using for the ecosystem services deviate that what you have presented for the States. The protection goals are a tool to have a discussion with the risk managers. I like how you have presented this as a communication tool for risk managers to take a final decision of the level of protection. But obviously, protection of the environment, protection of the diversity is part of the assessment that we are doing in EFSA as well. So my question is, how you experience us with the ecosystem services as a communication tool with directly with the risk managers?
Okay. You know, as I've said in the talk, I see ecosystem services primarily as a communication tool more than a tool that shows effects beyond those we're already identifying and protecting through conventional endpoints. And secondarily, as contributors to cost-benefit analysis, we actually do few cost-benefit analyses for protection of ecosystems. So that's not as commonly employed use. I'm not as familiar with EFSA and European practices, so I can't comment on that.
Okay. Thank you. I think this issue of, you mentioned quantifying what you can and describe the rest, I think it's something that maybe we should have in our minds for the panel discussion, and what it means when we come to issues like cost-benefit analysis. But for now, I would like to close the session and, or sorry, the section, and move on to section 3 and hand over to Helmut again.